So hello once again. This is time for revision questions about complex numbers. So we're going to do revision questions about complex numbers from different areas, but concerning with complex numbers. I try to find all numbers, or the numbers that can help you to understand complex numbers. So don't miss this chance. Let us go ahead for doing what? Those questions. So we have number one here. Number one is saying, given that z equal to 1 plus I to 3, express z power 122 in algebraic form. So now I'm going to answer number one. So number one, we have z equal to 1 plus I to 3. So we're going to express z power 112 in algebraic form. So this is algebraic form. Remember, algebraic form of complex number. Algebraic form of a complex number. Of a complex number is z equal to a plus bi. That is algebraic form. So now, if this is algebraic form of a complex number, we have z right there, which is in algebraic form. But they're asking us z power 12 in algebraic form, power 122 in algebraic form. So how can we express this in this form? So are we going to take this, then we multiply with power 122? So remember what we do, we use polar form of a complex number. Polar form of a complex number is polar form of a complex number. If you remember, it is z which is equal to r into bracket cos cos angle plus I sine angle. That is the polar form. So now when it has a power, by using the Mover theorem, when you have z power n, this becomes r power n into bracket cos n angle plus I sine n angle. So you have to remember this formula. Then after here, that's how we can convert from a polar form to algebraic form. So let us try to see how to express this complex number into polar form. So what do we need? We need the r as the modulus of z. We need the argument of z. Remember the r, which is the modulus of z, equal to square root of a squared plus b squared. So meaning that our r will be equal to root 1 squared plus root 3 squared. Then r equal to root 4, which is 2. Our r is 2. Then what is argument of z? We have tan alpha equal to b over a. Then tan alpha equal to b, our b is root 3 over 1. So tan alpha equal to root 3. So what is alpha? Alpha is tan inverse of root 3. So our alpha will be equal to, we're going to use the calculator, we find tan inverse of root 3. 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 So the answer is 60. So if answer is 60 degrees is pi over 3. It is pi over 3. Now remember, this is alpha. We need to find the argument. We use quadrants. Our a, because a is positive, you see here, our a is positive, even b is positive. So our a is positive, and b which is on y-axis is positive, even a on x-axis is positive. You see they meet here in the first quadrant. In the first what? Quadrant. So if they meet in the first quadrant, so remember that in the first quadrant, our angle equal to alpha. So mean that our angle will be equal to pi over 3, because our alpha is pi over 3. So our angle is pi over 3, which is the argument of z. So meaning that is z, which is 1 plus I to 3. Now its polar form is z equal to r, our r is 2 into bracket cos pi over 3 plus I sine pi over 3. This is our z in the polar form. But the question is asking z power 122. So from this formula, where you have z power n equal to r power n into bracket cos n angle plus I sine n angle, now z power 122 it will be equal to 2 power 122 into bracket cos 122 pi over 3 plus I sine 122 pi over 3. So this is the answer in the polar form. But the question is asking in the algebraic form. So I'm going to write that one in algebraic form. So the answer is 2 power 122 into bracket. What I do, I express this cos. I find the value of what? Cos 122 pi over 3. I use the calculator to get that value. Then now, what is the value of cos into bracket? The value of cos 122 times 60 degrees. So the answer is negative 1 over 2. Negative 0.5, which is negative half. Then what is sine of that? Sine of 122 times 60. So I get root 3 over 2. Root 3 over 2 I. So now, you see, we have a half here. So we can take a half out of the bracket. A half, if you take a half out of the bracket, so we get 2 divided by 2 into bracket negative 1 plus I root 3. Remember when you have like a power n divided by a power m, this is a power n minus m. So now, if I have 122 divided by 2 power 1, this is 2 power 122 minus 1. The answer is 2 power 121. So now our z power 122, the answer is 2 power 121 into bracket negative 1 plus I root 3. So this is our answer. Do you have any question here from number 1? I hope there is no any question. So let us go to number 2. The next number is number 2. We have done number 1. Number 2 is saying, given the complex number, we have our complex number, which is 3 minus I root 3 over 3 plus I root 3. This is our given complex number. So write that complex number in trigonometric form and z power 18 in algebraic form. So we are going to express this one into polar form. Remember the polar form of a complex number is z equal to r into bracket cos angle plus I sine angle. This is what we call polar form. This is the polar form of all trigonometry. Polar or trigonometric form of a complex number. So what is algebraic form? Algebraic form is when z equal to a plus bi. This is algebraic form of a complex number. Okay, now, so if you have the formula for polar form or trigonometric form and the form of what? Algebraic form of a complex number. So we have z. How can we express this one into polar form? So what we're going to do is like we have z equal to a complex number divided by a complex number. So remember when you have like z1 equal to r1 into bracket cos angle 1 plus I sine angle 1, and you have z2 equal to r2 into bracket cos angle 2 plus I sine angle 2. Then z1 over z2, answer is r1 over r2 into bracket cos angle 1 minus angle 2 plus I sine angle 1 minus angle 2. So, meaning that we're going to take a numerator, we express numerator into polar form, and we express denominator into polar form. So we let like t be z minus I root 3. So we're going to express t in the polar form. The magnitude of t, which is r1, is equal to square root of 3 squared plus negative root 3 squared. So what is the answer? R1 equal to, this is 9 root 9 plus 3 root 12, which is, 12 it is 4 times 3, and root 4 it is 2. That is 2 root 3. So our R1 is 2 root 3. So what is argument of t? The argument of t, which is angle 1. Then tan alpha 1 will be equal to b over a, which is root 3. Here we see, I told you that when you are finding alpha, tan alpha, we don't consider negatives. We just use positive sign. To be root 3 over 3. So meaning that alpha 1 is tan inverse of root 3 over 3. So we're going to find tan inverse of root 3 divided by 3. So let us use the calculator to find tan inverse of root 3 over 3. Then tan inverse of root 3, then divided by 3. Divided by 3. The answer is 30. 30 degrees is pi over 6. So our alpha 1 is pi over 6. Alpha 1 is pi over 6. So meaning that our t in the polar form, it will be 2 root 3, sorry, before I go to that, this is alpha. We're going to find the argument. So which quadrant that t is located? We have its a is positive and its b is negative. So now we are in fourth quadrant. This is the fourth quadrant. In the fourth quadrant, remember, our angle equal to negative alpha. So since our angle is equal to negative alpha, so our angle 1 will be equal to negative pi over 6. So therefore, our t will be equal to 2 root 3, which is r, into bracket cos of negative pi over 6, plus I sine of negative pi over 6. This is pi over 6. So that is t. So we have to write another complex number which is on denominator. This one, 3 plus I 3. So let maybe w equal to 3 plus I root 3. So now here, our R2, which is the magnitude of W, equal to root 3 squared plus root 3 squared. Answer is, this is 3, 9, that is root 12, which is 2 root 3. This is R2. So after getting R2,